Good morning, class. So you had your first set of math homework last night. Today I'm going to walk you kind of through some of the math problems. This is how we usually go over math. You can check over with homework help or you can use my videos. So I'm going to go through the problems. Usually I'll go over similar problems. I won't go over the exact problems. But for this case, since we're just starting out, here are the problems from last night's homework. So problem, what was it? 1-4 asked you to identify the type of shape and then to draw two similar shapes. So this we know it's a three-sided shape. This is our triangle, okay? And any other kinds of triangles we could do an equilateral triangle. All the sides of the triangle are the same side. Or we can do an obtuse triangle where we have one angle. Let's see, this is our angle right here. That angle is larger than 180 degrees. Like, wait a minute, time out, Mrs. Siegel. What are you talking about? Well, let me show you. So, if I were to draw a little dot coming straight down this triangle, okay, that's going to be the height of my triangle. If I were actually to draw, I could almost make like a little table, almost like if you're going to sit at the table to eat, right? That table right there indicates a 90-degree angle. Anything bigger than a 90-degree angle, so if our angle gets bigger than 90 degrees, that's going to be it's going to be more than 90 degrees, it's going to be an obtuse angle. So this is a triangle with an obtuse angle. This triangle, the angles are smaller than 90 degrees, but all sides are equal, so we call that an equilateral triangle. All right, and just an extra tidbit, this wasn't for your homework last night, but you will be using it a lot. Just to let you know, a triangle is half the size of a rectangle. We can even actually extend our triangle with a dotted line, and you can see when I extend it, it actually becomes a rectangle, or what we call a parallelogram. A parallelogram is when you have a shape with four sides, two sides that are equal or parallel. So, I'm going to erase that actually real quick. So we go back to our original triangle. And here we have, just to let you know, the area, the space within the triangle, is 1/2 of your base times your height. Your base can be found at the base of the table of that 90 degree. Your height can be found, it's going to be the side of that table of that 90 degree. Okay. The next shape we have, this is what we call a parallelogram. Meaning you have two sides that are parallel. Okay, when I think of parallel, I think of railroad tracks. They can go on and on forever, and they should never intersect each other, meaning they should never cross each other. So, in order to find the area of a parallelogram, again, area is the stuff inside, the space inside. That's going to be your base times your height. Here, I don't necessarily have my height identified. In order to do that, again, I can just draw the line, and then typically you will receive a measurement. Other types of parallelograms can be a square, and like we talked up there, another type of parallelogram can be a rectangle. Again, a triangle is all it is a parallelogram cut in half. Alright. The next shape you got was something like this. It's a pentagon. Pent is the prefix. Pentagon means 5. Right? So here are two different other shapes that you could have drawn that were like a pentagon. And then finally, the last one you had was something that looked like this. You had, let's see, I have to look again. You had a trapezoid, I believe. You had a trapezoid on its side. Now this is a trapezoid. If I were to actually turn it over, I would have something that looks like this. Okay. A trapezoid is, in order to find the area, it is 1/2 times the first base, this is the first base, plus the second base, this is the second base, times the height. This would be the height. Okay? So there you go. There's some different shapes. We'll be working on those throughout Chapter 1 and actually throughout the year. All right, I'm going to clear our board and I'm going to move on to the next. problem that I think would have posed some difficulty. I'm going to look at problem 1.5. So 1.5 gave us a number line, and it gave us a length of distance. Okay? So it said that our whole length right here is 28 meters. And we know that our length right, let's say here, is 11 meters. And we need to find the missing length right here. We don't know what that is. So there's a couple of ways you can solve this. If I know that my total length is 28 meters, I could put that down here. And I can say that 11 plus something, I don't know what that is yet, but plus something will equal. It will be the same as 28 meters. So I can say 11 plus something will equal 28 meters. Well, then how do I find that? What I'm going to do is I'm going to minus 11. I'm going to find the difference because the difference is this right here. The difference between 11 and 28 will give us our distance. So we're going to subtract 11 over here, subtract 11 over here, and now I find that my distance that I didn't know before is now going to be 17 meters. So this question mark is actually equal to 17 meters. All right, another way you can try that is just trying in numbers and seeing which fits. All right, thank you so much. The last problem is a number line. We're going to go through that in class. We should be pretty familiar with that, so I'm not going to go over that right now. And tune in to next time. I'll help you out with your next homework. Have a good day.